Okay. Sorry. My computer struggles. I don't know if this is going to work. Come on. Okay. Okay. We're going to try this. So I don't know at what point the other video cut out. Um, but I've shown all the work. Hopefully you can see these two answers that I got and why. X is greater than 1/2 and X is less than 2. I did forget to say the reason that this is and right here is because we have a less than sign. If we have a greater than sign, it's going to be or. That is for sure something I would write down in the notes. And that's just when you're dealing with absolute values and inequalities. That's the only time that matters. And honestly, something like this might not even be on the test. But it might still be good to write down. Okay, so this isn't asking us to graph it, but I always graph these because it helps me see what the interval notation is going to be. So I just, right here, they're both open circles. You just got to make sure the smaller number, right, is on the left-hand side. This is a number line, so make sure it goes in order. Then the 2 is pointing this way, and the 1/2 is pointing this way. And because this isn't and 1, we want them where they overlap, which is right here. So our interval notation is going to be parentheses, 1/2, comma, 2 parentheses. Just like that. Okay, now we're going to skip up some more to number 8. So this is the same thing, except normally when we're giving the absolute values, at least so far, it's always been the absolute values and is either equal to, greater or less than -7. But right here we have this -2 that is outside the absolute value. So the first thing is we need to get the absolute values by themselves. Absolute values on one side and everything else on the other. And that's often the case. If you remember, like this, when we're dealing with square roots, we have to do the same thing. So to get rid of that -2, I'm dividing, it's the absolute value is all being divided by -2, which means I'm going to multiply -2 and times by -2. And I times by -2, so I have to flip the sign. So my new equation is going to be x plus 5 greater than +14. So this right here, this is what I'm trying to solve. And because this is greater than, it's going to be an or. Okay, that's important. So I have x plus 5 is greater than 14, or x plus 5, flip the sign and change it to a negative. Okay, now I'm just going to solve. And again, I'm going to do these at the same time. So I subtract 5, subtract 5, subtract 5, subtract 5. So I have x is greater than 9 and x is less than -19. Now I'm going to graph. Both my x's are on the left-hand side, so I don't need to worry about flipping them. And you just got to remember smallest number on this side, -19, biggest number on this side. They are both an open circle. 19 is pointed this way, and my 9 is pointed this way. So now when I write it in interval notation, this is what I was talking about before. I start here, so I'm going from negative infinity all the way up to negative 19. Parentheses, and then this union, and I start back up at 9, and I go all the way to infinity. And remember, because it's an or, I just want all of my solutions. Okay, hopefully that all makes sense. So now we're going to come up to this. They want us to graph a system of equations. So, I'm going to add a page really quick and do some notes. You may or may not remember this. If you remember this, you can just skip forward. So when graphing, remember you've got your calculator, so you can always plug these in to make sure it's okay. When you plug it in your calculator, there's no way to plug in the greater than or like these less thans. So you could just plug in the equals. And that will get the point across. But when you plug it in your calculator, you need to always have it y equals something. So you'll have to solve for this. When I graph by hand, if I'm not using my calculator, I always like it the same thing, where I have y equals mx plus b. So it's just a personal preference of mine. I think it's way easier to graph when it's in this form. So my first step when graphing is always to get it to be y equals whatever. That way too, I can plug it in my calculator and solve to make sure it's correct. So when I have it in this form, my m is my slope. And remember, slope is rise over run. You can remember it's how we move, which is how I remember the m. Slope is how we move. And a formula for it, if needed, we don't need it in this case, but it's y2 minus y1 divided by x2 minus x1. Now our b is our y-intercept. So our b is going to be when x is 0, we have that b value. It's also where we start when I graph. So if I have some equation y equals 2x plus 1, my slope is 2. So what that means, remember, rise over run. So I've got 2, and then I have like an imaginary 1 below. Okay, so what it means is I'm going to go up 2, rise 2, run 1. And then my y-intercept is 1. So I just know I'm going to have a point at 0, 1. So now when I graph this, well, let me change to, when I graph this, my y-intercept is where I start. So I start at 1. Okay, that's what this tells me right here. I start at 1. So I put a point there, and then from there I move for my slope. So my slope is 2, so I rise 2, and then I go over 1. And then I could keep doing that. I go up 2, 1, 2, over 1, and so on. I really just need 2 points, but that's going to be my line, okay? So that's graphing. So they want us to graph these. As I go along, the inequalities, it will make sense what I'm doing. I'm hoping this will click and you'll remember it. But first I just need to graph these. So I want to get them both to be y equals something or y is less than something. So for this first one, I have x minus 3y is less than 6. So I want to get y by itself. So I'm going to subtract the x. You could bring over the y, you can add the 3y. If you do that, you'll get the same thing. So if you were like, in my head, I was doing that, you keep doing that and just at the end, see if you get the same answer as me. And I subtract x, sorry. So now I have negative 3y is less than 6 minus x. Now I divide by negative 3. Gotta divide the whole thing by negative 3. So I have y is less than, oh, but it's a negative, so I gotta flip the sign. Greater than, and I'm gonna separate them. I'm gonna say 6 divided by negative 3 minus x divided by negative 3. So now I'm gonna have y is greater than 6 divided by negative 3, it's just negative 2. And then minus, so I've got this negative over negative, so it's going to be positive 1/3 x. If that's confusing to you, this right here is the same thing. You can use this and graph it. That's totally fine. I just saw negative over negative. And in fact, I'm going to change it even more just because I like to have my 1/3, my slope in front and my y-intercept behind. Okay, so that's one of them. Now this other one, I've got 3x plus y is greater or equal to negative 3. So first, I'm going to subtract 3x, subtract 3x. So I have y is greater or equal to negative 3 minus 3x, which is what I want. Except I'm just going to, again, I'm just going to put my x in front. So I've got negative 3x minus 3. You're okay to flip things, just make sure the signs stay with them. So this is a negative 3, so this has to be a negative 3. This is a negative 3x, so that has to be a negative 3x. I just like having that x in front because it's that form, it's this form, the y equals mx plus b. It's just easier for me to see. So I've got this and this. So now I'm going to graph them. So if you remember when graphing inequalities, the only difference is that if it's one of these, it's a dotted line. And if it's greater than or equal to, it's a solid line. I don't know if you remember that or not. So for this one right here, I'm going to do first. It's going to be a dotted line because it's not equal to, it's just greater than. So I start at negative 2. I'll make a point. And then I move with my slope. So my slope is 1/3. So I go up 1 over 3. So right there. I don't know why it keeps doing that. Over 3. So now I can just draw a line and it's dotted. So this is not going to be totally straight, but we get the point. So that's my first line. Now my second, I'm going to switch colors so you can see. This has that greater than or equal to, so it's going to be a solid line. So I start at negative 3, which is right here. It's awfully close. I should have spread this graph out more. Then my slope is negative 3, which remember is just negative 3 over 1. So I rise negative 3. Negative, oops,